Lab 9, I chose to make a miniature automated bowling alley system. This project combines custom designed and 3D printed components, Arduino-based sensor inputs, and processing-based score visualization as pictured over here. I designed and 3D printed the entire alley surface, including the gutters that keep the ball on track. The pins themselves are also custom 3D prints as pictured here. And in addition, I also printed the mounting bracket that secures the solenoid to this servo, creating a guided channel for the ball to launch smoothly. Each pin stands over a small photodiode sensor. When a pin falls, it blocks light from reaching the sensor, and the Arduino recognizes that pin as down. So I can demonstrate it like this. Pin 1 is down, and that change is reflected on the processing window. All of the electronics feed into an Arduino Uno Rev 3, which I have positioned a little bit behind the system, if you can see it from this angle. And I use a potentiometer, pictured here, to adjust the servo angle. And the servo position influences the launch trajectory of the ball. By turning the potentiometer, I can fine-tune how the ball is delivered down the lane. And the Arduino converts the potentiometer reading into a servo signal and adjusts the angle precisely. Here is the solenoid launcher, which is also integrated into a 3D printed component. Pressing this button here energizes the solenoid and sends the ball down the lane. So just demonstrate without the ball first. You can see it activate, and when I run it with the ball, it will knock down the pins. On my computer, I have a processing program which receives data from the Arduino. Each pin's state is displayed on screen, white for upright and gray for knockdown. The code running and processing applies standard bowling scoring rules for strikes, spares, and cumulative scoring, just like in a real game. As each ball is thrown and pins are counted, the scoreboard updates, and if all pins fall on the first try, that's a strike. 2 tries to get them all down is a spare, and any other combination is an open frame. The program keeps track of the entire game from frames 1 through 10. So I'm probably never going to get a strike on this setup just because it's not like real bowling, but just to show what that would look like on the processing window, I'm going to simulate throw, knock the pins down, and as you can see, it displays a strike and all the balls are down. Now let's say you were to get a spare. So I'm gonna just try my best for this first throw. Pretty good, actually. Got 4 pins down. So instead of resetting the ball, just because I don't know if I'm gonna be able to knock down the rest, I'm just going to simulate another throw, manually knock them down. And as you can see, it actually reflects that I got a spare. Okay, so now for the demonstration. So I'm going to aim it down the lane, launch it with the button, and I got knocked down 3 pins. So that is reflected over here. And so I'll just manually return the ball, and I will aim it again, maybe for the right this time. Just got 1 more, but that was my second ball, and I got 4 points in that frame. So now, in order to get the balls reset for the second frame, I can actually push this pin, this dowel pin I designed to push the pins back up. Just like that, it's ready for the next frame. To illustrate what's happening when I'm resetting the pins with the dowel pin, let's go underneath the system. You can see that component right there. It was designed to push the pins back up. So I'm going to press this, and I'll show you what it does as I press it. As you can see, pins are now up. This system shows how custom 3D printed hardware, sensors, and software work together. The physical alley, pins, gutters, and solenoid mount I designed and printed are all integral to the mechanics. The Arduino handles sensor inputs and outputs, while processing manages the visual display and scoring logic. In short, my project brings together digital and physical design, electronics, and coding to recreate the excitement of bowling but on a miniature scale. I hope you enjoyed my demonstration.